Percent yield is the way to tell if you're doing a reaction correctly percent yield is a way to see how complete the reaction is. So it's looking at how much you should have gotten versus how much you actually got. So for example, if you're following a recipe and it says it should make 24 cookies, but you only make 20 cookies, then it's comparing how well you did at baking those cookies. That's kind of like what percent yield is. There's two parts to percent yield. You have the actual yield versus the theoretical yield. The actual yield is the amount that you actually get in the lab setting. So you have to be told that amount in the problem. The theoretical yield is an answer that you always have to calculate. And so that's what we've been doing when we've been solving our stoichiometry problems, is we've been determining the theoretical yield. So let's look at two examples. In our first example, we're creating methanol by the reaction of carbon monoxide and hydrogen. So it's telling us that we're starting with 75 grams of carbon monoxide and it's producing 68.4 grams of methanol. What is the percent yield? So that's what we're looking for. We're looking for the percent. The actual yield has to be given to you in the problem. The actual yield is the actual amount of product that was formed. So since methanol is our product, this is the actual yield. And so it's going to become our job to figure out the theoretical yield, so then we can find the percent. So to find the theoretical yield, you always start with the given that's listed with the reactant. In this case, it's 75 grams of carbon monoxide. And then you do stoichiometry to get to the grams of the product. So the first step of stoichiometry is to convert the given to moles. So that's what we're going to do first. Bring your grams of carbon monoxide to the bottom, moles of carbon monoxide on the top. Based on our roadmap, we know that 1 goes with mole, and the molar mass would go with carbon monoxide, or grams. So carbon monoxide, carbon is 12.01, and oxygen has a mass of 16. Again, those are coming from the periodic table. So that's a molar mass of 28.01 grams per every 1 mole. So 1 mole has a mass of 28.01 grams. Now if we were to stop here, multiply and divide, the grams would cancel and we're at moles of carbon monoxide. So the second step to stoichiometry is your mole ratio. So bring moles of your given to the bottom, and moles of the unknown substance would go on top. Well, since we're looking for the percent yield of methanol, methanol is our unknown substance, so we would put that on top. Then remember, the numbers you use for the mole ratio are the coefficients in the balanced reaction. So we have 1 carbon monoxide and 1 methanol, so they are both 1s. Now if we were to stop here, multiply and divide, our moles of CO would cancel out, and we're left with moles of methanol. But we want to know grams of methanol, because that's how we would determine the theoretical yield. So we're going to convert from moles to grams. And then based on our roadmap, we know 1 goes with mole, and then the molar mass of methanol would go with grams. So looking at the periodic table, carbon has a mass of 12. Hydrogen, and we have 4 hydrogens, has a mass of 1.008, and then oxygen has a mass of 16. So that gives us a molar mass of 32.042 grams, and that's for every 1 mole. So back to our table here, we have 1 mole, so that would be 32.042 grams. Then if we multiplied and divided, our moles would cancel, giving us grams. So now we can take our calculator, multiply, divide, multiply, divide, multiply, divide, and we can come up with our theoretical yield of 85.8 grams. Now again, the one that we calculated is the theoretical yield. So to find the percent yield, which is what the question is really asking us to do, we take the actual yield and you divide it by the theoretical yield. Now you can pause here and double check yourself. The theoretical yield should always be less than the actual yield. You cannot produce more than what you can based on your given amounts. So the theoretical yield should always be larger than the actual yield. And then we're going to multiply by 100 to get our percent. Now we have 3 sig figs in our given values, so we're going to do 3 sig figs in our percent. So we have a percent of 79.7%. Now that's a pretty good yield if we're thinking about this in the industrial setting. To have that percent, that's pretty high, and your boss would be happy. All right, one more question here. Huge quantities of sulfur dioxide, I'm sorry, there's a typo there, that should say zinc oxide, are produced from zinc sulfide by means of the reaction below. If the actual yield is 3,550 grams of zinc oxide, what is the percent yield? I apologize, I'm just now realizing that they did not give you the mass of zinc sulfide. So I'm going to go ahead and tell you the mass of zinc sulfide is 4,897 grams. I apologize. All right, so now looking at what we're given, and we're looking for the percent yield. Remember, the actual yield has to be given to you in the problem. So the one with the product is the actual yield. So we're going to take the one given to you with the reactant, and we're going to convert that to the product. So we're going to go from grams of zinc sulfide to grams of zinc oxide. So we set up our stoichiometry. First step is to go from grams to moles. Always need to be in moles. Based on our roadmap, 1 goes with mole. And then the mass of zinc sulfide, looking at the periodic table, 65.39 for zinc, 32.07 for sulfur, and we would get 97.46 grams for every 1 mole. So 1 mole is 97.46 grams. If we were to stop here, multiply and divide, we would be at moles of zinc. So that's step 1. The second step means that we need to do the mole ratio. So we bring moles of zinc sulfide to the bottom, and we put moles of zinc oxide on the top because we want to know the percent of zinc oxide. Then we use the coefficients from the balanced reaction in our mole ratio. They both happen to be 2. Once we've used our mole ratio, then we can convert to whatever unit we need it to be in. And so our actual yield is in grams, so we want our theoretical yields in grams. So we bring down moles of zinc oxide, and we would put grams of zinc oxide on the top. Based on our roadmap, 1 goes with mole, and the mass from the periodic table would go with grams. So zinc is 65.39, oxygen is 16, and so that's a total of 81.39 grams for every 1 mole. So 1 mole, 81.39 grams. Now we can stop here and we can multiply and divide. As we multiply and divide, grams of zinc sulfide cancel, multiply and divide, moles of zinc sulfide cancel, multiply and divide, moles of zinc oxide cancel, leaving us with grams. So we would get a theoretical yield of 4,090 grams. So we're putting that decimal there so that that last 0 is also significant, giving us our 4 significant figures. Remember, the answers to stoichiometry are your theoretical yield. So to find our percent yield, we're going to take the actual and divide it by the theoretical. Multiply by 100. Because our actual yield does not have a decimal, that means there's only 3 significant figures. So our percent is going to be 3 significant figures, and it would be 86.8%. So this is an even better yield than the previous question.